Hello everybody, we're getting ready to do 3.9, lesson 3.9, absolute value equations and inequalities that include absolute values. Get a hold of me here for PowerPoints or video or any other materials. 3.9, absolute value equations and inequalities. We've got 30 points here of note-taking. If you have a note-taking guide, get that ready. Overview of this section here, the absolute value of x, written as bracket absolute value x bracket, refers to the quantity x without regard to whether it's positive or negative. Geometrically, absolute value x represents the distance from 0 to x on a number line. Since -2 and +2 are each 2 units from 0, absolute value 2 equals 2 and absolute value -2 equals 2. Solving absolute value equations, when we have a setup like this, solve absolute value equation, remove the absolute value sign by accounting for two possibilities. Quantity inside the absolute value sign is non-negative, in which case simply remove the absolute value sign. So x minus a greater than or equal to 0, then x minus a equals x minus a here. The quantity inside the absolute value sign is negative, in which case remove the absolute value sign by placing a negative sign in front of the quantity. So if we do that, if x minus a is less than 0, then absolute value x minus a would equal the negative of x minus a. We go on to an example here, solve for x. So we have absolute value x minus 1 equals 4. If the quantity inside the absolute value sign is non-negative, then x would equal 5 here in this case. If the quantity inside the absolute value sign is negative, then we put a negative here in front of the parentheses here. So x minus 1 absolute value equals the negative x minus 1 equals 4. Negative x plus 1 equals 4. Negative x equals 3. X would equal -3 then. The two possible solutions for x are 5 or -3. So we solve for a positive and a negative solution for an absolute value like that. So solve for x, 2x plus 3, absolute value plus 4 equals 5. If 2x plus 3 absolute value plus 4 equals 5, then 2x plus 3 absolute value equals 1. Thus, 2x plus 3 equals 1, so 2x equals 1 minus 3 equals -2. And x equals -2 over 2 would equal -1. Or 2x plus 3 equals -1, so 2x equals -4. And x would equal -4 over 2, which would equal -2. You should verify that both roots satisfy equation, so solve and check. So we're going to solve and check for this here. So -3 equals x. Check. So you stick in a -3 there. 3 minus 3 equals 2 times negative, which is what? -6. Absolute value of -6 does not equal -6. So 3x equals minus 3 equals 0, 3x equals 3, and x equals 1. So it would not equal a negative. It would have to be 3 and x equals 1 here for this situation. So we check that. If x equals 1, then x minus 1 equals 2x. Absolute value of -2 does equal 2. Hence, x equals 1 is the only root of the absolute value equation. Interpreting absolute value inequalities, absolute value inequality x, absolute value x minus a less than d represents set of all points x that are less than d units from a. For example, the inequality of absolute value t minus 68 degrees is at less than 3 degrees states that the temperature t is less than 3 degrees from 68 degrees, which means that t is between 65 and 71 as shown. So here would be a graph of this situation here. 68 plus 3, so it'd be 68 minus 3 would be here. 68, and then this is the upper limit, and this will be the lower limit. Solution of t minus 68 degrees, absolute value, is less than 3 degrees. Inequality t minus 68 degrees is greater than 3 degrees states that the temperature T is more than 3 degrees from 68 degrees, which means that T is less than 65 degrees or greater than 71 degrees. Solving absolute value inequalities here. To solve an absolute value inequality algebraically, remove the absolute value sign accordingly to follow the rules where D is a positive number. So AX minus B, absolute value less than D, then negative D would be less than AX minus B is less than D. So we have a complex inequality here. And we have this is greater than D, so we do the same thing here. Only thing is now AX minus B is less than negative D, or AX minus B is greater than D. Solve and graph a solution set of absolute value 2x minus 1 is less than or equal to 7. We have this statement here that negative 7 is less than or equal to 2x minus 1 is less than or equal to 7. Add 1 to each member of the combined inequality. So what does that give us here? So when we add 1, we get that. We get negative 6 less than or equal to 2x, and 2x is less than or equal to 8. Divide each member of the combined inequality by 2. So we divide everything by 2. And we get negative 3 is less than or equal to x, and x is less than or equal to 4. Graph the solution set. Here would be the graph here. Here would be the lower limit, and the upper limit would be up here. So that will be the graph of this solution set here. If 5 is less than absolute value 2 minus x is less than 6, and x is greater than 0, what is the possible value of x? Remove the absolute value sign. If 2 minus x is greater than 0, and then 5 is less than 2 minus x is less than 6, so 3 is less than negative x, and x is less than 4. Multiplying each term of the inequality by negative 1 will change the direction of the sign. Since it is given that x is greater than 0, x is greater than 0 up here, disregard this solution. If 2 minus x is less than 0, then 5 is less than negative 2 minus x is less than 6, or equivalently, 5 is less than x minus 2 is less than 6, so 5 plus 2, so we're going to get rid of this 2 here. 5 plus 2 is less than x, and x is less than 6 plus 2. 7 is less than x, and x is less than 8. Therefore, x can be any number between 7 and 8, such as 7.5. And that is the first part of 3.9. Order more PowerPoints and videos at this email here. Thank you very much.